Dear student, in this video, I'll be talking about S attributed syntax directed definition, L attributed syntax directed definition, applications of syntax directed translation. The first one is S attributed syntax directed definition or S attributed definitions. A syntax directed definition is S attributed if every attribute is synthesized attribute. So as you know that we discussed earlier that if an attribute gets its value from its children or from child, I mean to say that from its bottom, if all the attributes are of same thing, then we call it as a S attributed syntax directed definition. We can have post-order traversal of parse tree to evaluate attributes in S attributed definitions. So it means that it uses post-order traversal to evaluate every node of an S attributed syntax directed definition. Now, what is post-order? You know that the post-order is nothing but it visits the left first, then the right child, then the root it will visit. So similarly, so we use the post-order traversal to evaluate every node of S attributed syntax directed definition, where N is the starting node. So you know that if I call this function post order of N, that is nothing but the starting node, for each child C of N from the left, you know that it starts from the left. So see that, so C is a child node of N. So if C is once again a root node, what it does is it calls the post order of C. It means that once again we call a function post order of C, it becomes N. If once again this C is a root node, once again it calls to the left of it. So that will be get evaluated. It continues and then it evaluates the right and then it evaluates the root node and then it comes back to the right of it. Then it goes to the root of it. So this process will continue until every node of this particular tree gets evaluated. It means that evaluate the attribute associated with node N. So when you call post order of C, once again, it becomes N with respect to the subtree. So in this way, this particular S attributed syntax directed definition will get evaluated. So in case of S attributed definitions can be implemented during the bottom-up parsing without the need of explicitly create a parse tree. You know that. So every attribute gets its value from the bottom so that you need not to create a parse tree. You can directly call the post order of a root, automatically it will be get evaluated. Finally, you will get the final result. So if you just see an example, so why we call this as an S attributed syntax directed definition is, if you just look at the semantic rule, every attribute value is getting its value from its child node or from the children. For example, for the first rule, the semantic rule is L dot value is equals to E dot value. It means that the value of E, attribute value associated with E, will be passed to the L. If you just take the second node, that is E tends to E plus T. Now you have two children. One is E, the other one is T. The value associated with this particular E and T are VAL. So then once it gets evaluated, that is the left of it, and then it is the right of it, then finally it will be get evaluated. So similarly, E tends to T, the value of T will be associated, will be passed to the E. Similarly, the other, every node will be get evaluated. If you just see the annotated parse tree for this particular grammar for a string 5 plus 3 star 4. So it means that as already we discussed about L tends to E, then E tends to E plus T. Once again, E tends to T, T tends to F tends to digit. You know that we construct a parse tree. What is an annotated parse tree? At every node, the value, attribute value associated with every node will be represented using an annotated parse tree. As we said, since it is an S attributed syntax directed definition, its value will be get evaluated from the bottom as well as from the left to right and then to the root. So it makes a call to the function L with the value L. In turn, this L will make a call to this E. Once again, the left of this E is E. The left of this will be T. T left is F. F left is digit. So this will get evaluated and then it will be passed to the next level, to the next level, to the next level. Once it gets evaluated, then as per the post order, so then it goes to the right of it. Once again, the right is once again a root node. It calls to the left of it. This will be get evaluated. Once again, it comes to the right. Then this will be get evaluated. Since this is the right child, it gets evaluated. Since the left is also over, right is also over, then finally the root will be get evaluated. So once again, this is the left, that the right turn will be the return value. Automatically the return value from this will be 17 because it will be get terminated. So this is how the S attributed syntax directed definition will be get executed. One thing you need to observe that every values are coming from bottom to top. That's why it is called as S attributed syntax directed definition. What is L attributed definition? A syntax directed definition is L attributed if the edge in a dependency graph goes from left to right, but not from right to left. Whereas in case of the synthesis attribute, it is going from right to left. Whereas in case of this, it always moves from either from left to right or from top to bottom. So in case of inherited, if there is a production, A tends to X1, X2 up to Xn, you know that this is a production, and there is an inherited attribute xi dot a. So assume that one of the variable is an inherited attribute computed by a rule associated with this production. Then the rule may be only used as, so the rule, it means that this is a production, then you are supposed to write a rule to get its inherited value. The rule may be the inherited attribute associated with the head A, that is, it means that the xi dot a is its inherited value is associated with A. It means that it is getting its value from its head. I mean to say that it's from parent. Either inherited attribute or synthesis attributes are associated with the occurrence of symbol x1, x2 up to xi minus 1. Assume that you are looking for an inherited attribute for xi. Before that, whatever the attribute value associated with the grammar symbol from x1 to xi minus 1 may be an inherited, may be a synthesized, but if we get its value from the left, always it is an inherited attribute. So inherited are synthesis attributes associated with this occurrence of xi itself, but in such a way that there is no cycle in the graph. It means that the inherited attribute gets its value by itself. The possibility of getting the inherited value is, one is from parent to child. It means that from head to the child, or from sibling. I mean to say that from the left to the right. The other one is itself. So these are the S attributed syntax directed definition. What is an application of syntax directed translation? So it helps in generating the intermediate code generation and construction of syntax tree. You know that when we construct the syntax tree, when you traverse through this tree, or when you just go through this tree, you will be able to generate the intermediate code. That's an application of syntax directed translation. So in case of construction of the syntax tree, leaf nodes, it means that we construct two types of nodes. One is the leaf node, which consisting of an operand and followed by the value. The other one is the intermediate node, which consisting of an operator followed by the number of child or the children associated with particular node. So these are the two nodes we create when you are constructing a syntax tree. So if you just look at the semantic rule, I mean, it is the syntax directed definition to construct a syntax tree. As you know that this is a production given, and the semantic rule for these productions are as follows. If you just look at this, E tends to E1 plus T. This value of E will be evaluated based on the value of E1 based on the value of T. So how we are going to write the semantic rule for this is E dot node is equals to new. We are going to create a new node, that is the node which consisting of an operator followed by two operands. One is the left child, the other one is the right child. I mean to say that the left operand as well as the right operand. Please make a note that in case of construction of parse tree or the syntax tree, what we do is we create an intermediate node which consisting of an operator followed by the operands. Similarly, we create a node for this particular minus operator also. So, and for the star also. Wherever you have a direct synthesis attribute, then you need not to create a node. Automatically, the value will be passed to the next level. So, you can just observe that E dot node, T dot node, T dot node to E dot node, it gets its value directly. And then E dot node will be passed to the T dot node directly. Whereas when it comes to the leaf node, we create a leaf node which consisting of an operand, I mean to say that an identifier, followed by the entry into the lexical analyzer, or it gets its value from the lexical analyzer. And similarly, if it is a number, then we create a leaf node, which consisting of a keyword called num, followed by the value associated with this particular number. So this is how we are going to construct a syntax tree. What we do is we'll use this rule to construct the syntax tree. So in constructing the syntax tree, please remember that we create two types of node. One is an intermediate node consisting of an operator followed by the operands, whereas my leaf node may be consisting of an identifier, or it may consisting of a number. So the steps we are following to construct a syntax tree are as follows. Convert the given expression from the infix expression to postfix expression. Create the object of type node or a leaf. Sequence of objects are created based on the expression. You're supposed to create the object of either the node or a leaf based on the requirement. Example, construct a parse tree for an expression a minus 4 plus c. So in order to construct this parse tree, you must have written the semantic rule. This particular expression can be obtained using the previously shown semantic rule. So you may construct the x followed by x star y minus 5 plus z also. You may create a star b plus c minus d whole star followed by a star b plus b. You can construct all these syntax tree using the same semantic rule. I'll be taking the first one example, a minus 4 plus c. The rule you are supposed to follow is convert the given expression into postfix expression. So you will get a postfix expression as a4 minus c plus. Then create an object for each node or leaf node. For example, first we are supposed to construct a leaf node for a particular variable a. I create a leaf node. So you can just observe that for a, we are giving an abstract name as an identifier, followed by entry into the syntax analyzer or entry into the lexical analyzer as a. And then the next node or the next leaf we are going to create is for 4. So you can just observe that in case of a, we have given as id, whereas in case of the number, we have given it as a number, followed by the value associated with number is 4. And then for minus, so you're supposed to create a node. So in order to create a node, you must have operator followed by the two operands. So you have created a nodes for this P1 and P2. You need not to create P1 and P2 once again. What you will do is you will give the reference of this. So please observe that carefully. What we are doing is we are representing each node using either a leaf node or an intermediate node. What happens is, in order to get its value for P1, to get its value, what we do is we'll directly reference to P1. We'll get the value of P1 as well as we'll get the value of P2. So for similarly, for P4, why we construct P4 is, that is C. For C, we are going to create a P4, which is a leaf node. Once again, it's an identifier. That is, make an entry into the symbol table. So then finally, you are supposed to create a plus. So you can observe that. So my node consisting of two things. When you construct a parse tree for this, what happens is you are supposed to evaluate a minus 4, then c, a minus 4 plus c. So for that, what we do is we'll construct a minus 4 first, which you can create it using the P3. Then we create a node for plus using two operand. One is a minus 4 result plus c. So that's what we are doing it. So we are going to construct a syntax tree using this. So when you construct a syntax tree, you can just observe that. First, what we do is with respect to minus, we create. So we are creating the with respect to minus. So before that, we should have a node P1. We should have a node P2. That will be represented as P1 is representing the ID. P2 is representing the number, which you are going to refer by using the an arrow from this particular node. So it means that this, in order to evaluate this, you must have a value of this. You must have a value of this. This you can get it directly using this particular node. So you will call a function to get the value of this. We'll call a function to get its value. Once this gets evaluated, so we'll get the left operand of the plus, and then you will get the right operand from the ID directly. So then it gets evaluated. Then it goes to the E. So you can just observe that the dotted line shows the a normal syntax tree, whereas my each node shows that how the value will be get evaluated at every node. So you can use the same syntax tree. You can just observe that I have a plus. So for plus, you are going to create a node For minus, you have created a node. For ID, you have created a node. For number, you have created a node. You can just observe that it is getting its value from the number. So then ID is getting its value to the T dot node. T dot node is going to get its value from E dot node. Finally, this E dot node will get its value after evaluating this particular node. Similarly, it happens with respect to E plus T also. So this is how we are going to construct a syntax tree using a syntax directed definition. It's an application of syntax directed translation. Similarly, we do it for the L attributed syntax directed definition. It's not completely an L attributed syntax directed definition because it consisting of both combination of synthesized as well as inherited attribute. You can just observe that this particular grammar can also use to generate a string of plus minus within the parenthesis. You can have an expression. So this is a given grammar. For that, we write the rule, that is E dot node is going to get its value from E dash dot synthesized value, but this particular T is going to get its value from the T. I mean to say that E dash is going to get its value from T because T is going to give the value of ID or number, as we discussed in the previous class about the dependency graph. Similarly, we use the dependency graph to write the semantic rule, or we use the semantic rule to represent the dependency graph. So similarly, to evaluate this particular E1 dash, you must have a value of T. You must have a value of E1 that you are going to get it from. One is you are going to get it from directly from T dot node. The other one is the inherited attribute value you are going to get. So that once you get evaluated, then this becomes the E dash dot inherited value, because it becomes a value to the next level, because you can replace this E by, once again, either by minus TE or you can replace by plus TE. Once again, this becomes an inherited attribute. Similarly, for this, to evaluate this particular node, I mean to say that the minus operation, you must have two operands. One is T, the other one is E1. So one you get it directly from T dot node, the other one you get it from the inherited value from the previous node. I mean to say that from the sibling. So that's why we write it as E dash dot inherited, then comma T dot node. You can just observe that wherever you have an operator, we are creating a node. Wherever you have an identifier or a number, we are creating the leaf node. Similarly, this will be get evaluated. So once you get this E dash dot epsilon, it means that this synthesized value becomes synthesized value itself. So it means that the inherited value becomes the synthesized value, then synthesized value becomes the synthesized value for the next level. Similarly, T dot node is equals to E dot node. So similarly, we create a leaf node for identifier, leaf node for the number. So similarly, we write the dependency graph for this particular given grammar. So here you can just observe that E tends to TE dash. So why we have written the rule as E dash dot inherited is equals to T dot value, because it is getting its value from the sibling. That's why we are writing that E dash dot inherited is equals to T dot not node. You can just observe that. So in order to evaluate this particular expression, so you must have two operand. One is this operand, the other one is this operand. This operand for the minus, you need one operand which is available in some other subtree. So that's why we have written as E dash dot inherit is equals to T dot node, and then we get T dot node directly. Then we have written the expression as E dash dot inherited is equals to E dash dot inherited plus T dot node. You can just observe that in case of this, E dash dot inherited is equals to new of node of plus E dash dot inherited comma T dot node, which is this E dash dot node, the node which you get it from this particular node. So then this becomes the, once again, in the inherited attribute. That's why we have written the rule as E dash dot inherited is equals to node of plus E dash dot inherited comma T dot node. So this becomes an inherited attribute once again. So once this becomes an inherited attribute, then for the next level, once again, this becomes an inherited attribute, because you will have evaluation of this. Once you apply the epsilon, this becomes a synthesized attribute. This synthesized attribute will pass to the next level. It will be passed to the next level. It will be passed to the next level. So this how this particular syntax tree will be get evaluated. The only difference between this to the previous dependency graph is that we create a node for every grammar symbol, or at every node we create a node or a leaf to evaluate the particular expression. So this is how we are going to discuss about the syntax directed definition for synthesized attribute as well as L attributed syntax directed definition. Thank you.